All right, the next example will be example 3. Let me go through this right here real quick to make sure we remember up here on the board. All right. Consecutive integer word problems we saw last year. We did it in 2 lessons last year. We did consecutive integers one day. The very next day we got to even and odd integers. And what I want you to remember about consecutive integers is they go up one at a time. Integers are non-fractions. So if I'm at 6, the next integer up is 7, the next integer up is 8. They go up one at a time. But when you deal with algebraic consecutive integers, we don't know the first one. So we're going to call the first one whatever. I'm going to call it n. I usually call it n. Call it x, call it y. It doesn't matter what you call it. Okay, you can call it I if you want to for integer. Doesn't matter. Okay. Then you rely on the pattern to use the same variable to represent all the integers in your list. So if n is any integer, the next one up is one bigger than that. The next one up is one bigger than that, which would be n plus 2. The next one up is one bigger than that, which is n plus 3, and so on. Right? That's how you deal with consecutive integers. That way we use one letter to represent multiple things. The first integer, the second integer, the third integer, the fourth integer, and so on. All right, so they refer to them in that way. Twice the sum of the first and third is 15 more than 2 times the second. All right, that kind of stuff. All right. Consecutive even integers would be numbers like 6, 8, 10. Looking at the pattern of that, it's a plus 2 pattern. All right, the pattern is what establishes how to create the integers. So again, if the first integer is n, I always start off with a letter to represent the first one, and then I apply the pattern to get the multiple ones. The next one up is 2 bigger than that, the next one up is 2 bigger than that, and so on. Okay, neither one of those tends to bother anybody. This next one, though, bothers people. 5 is an odd integer, right? What's the next bigger odd integer?
7.
7, then 9, and so on, right? How do I get from one to the other?
Plus 2.
Add 2. Okay, and that's the thing that bothers people. We're using an even number 2 to describe odd integers, but that's what the pattern is. Again, the pattern establishes what it looks like algebraically. So, if this is an odd integer, the next bigger odd integer is going to be 2 bigger than that, and the next one bigger than that is 2 bigger than that, and so on. All too often I see people want to put n plus 1, n plus 3, because 1 and 3 are odd, right? Okay, so let me convince you of this. Maddie, pick a number that's even. 4. Maddie picked 4. So, if I apply this rule to the number 4, 4 is that, what's the next number up?
8.
What's the next number up? 8. Alright. Now, Quinn, pick an odd number.
7.
7. Okay, 7 is an odd number. If I apply this rule to 7, what's 7 plus 2? And 7 plus 4? 11, right? So, the plus 2 and plus 4, if n starts off odd, I continue to get odd numbers by adding 2 each time. If n starts off even, I continue to get even numbers if I keep adding 2. Alright? If I have this one that people want to do, n plus 1, n plus 3, which I've seen people do, let me show you this. Don't write this down, this is wrong. And let's take Quinn's odd number 7, right? What's 7 plus 1?
8.
And 7 plus 3?
10.
It's not consecutive odd integers, it's just a big jumbled mess. Alright? So again, this is wrong, it will never be right. So when it says consecutive odd or even, they look the same algebraically. The difference is, what does n represent? If n's even, everything's even. If n's odd, everything's odd. One other thing that's going to come into play here shortly, not today, but shortly, will be consecutive multiples. Consecutive multiples of, let's say, 7. Alright. Multiple of 7 is something that divides by 7. Emily, give me a number that divides by 7.
14.
Perfect, 14. What's the next bigger number that divides by 7? 21. Then?
28.
And then?
35.
42, and so on, right?
Yeah.
Multiples of 7. Now look at the pattern there. How do I get from number to number?
7.
Plus 7. So what do you think the algebraic structure would be for consecutive multiples of 7? If n is the first one, then the second one would be n plus 7, then n plus 14. It's exactly just like that. Now the book thinks this is a good way of doing it, which isn't wrong, but they do it this way. 7 times n, 7 times n plus 1, 7 times n plus 2, and so on. Okay, that's also consecutive multiple of 7. Let's say n equals 3. 7 times 3? 7 times 4? 7 times 5? See, it's still consecutive multiples of 7. The problem there, though, you'll get n equals 3, you still have to multiply by 7 to get the answer. Here you get n equals 21, you're ready to go. So when it says consecutive multiples of number, do it like that. Whatever that number is the pattern. So n's the first one, add the number, add twice the number, add 3 times the number. That's how you handle that situation when it arises, which will be probably the next 10 lessons. And I'm not going to teach it again. Okay, so it'll show up on your lesson. Just know that's coming up. Example 3. Maddie, it says find 3 consecutive even integers. What do they look like?
N plus 2, N plus
Perfect. n plus 2, n plus 4.
Nice.
4.
She saw the word even. She remembers even's a plus 2 pattern, so she establishes the unknowns in that way. It did say find 3, so she named 3. And this is the first, the second, and the third. You don't have to write down first is n, second n plus 2, third n plus 4. Putting them in a list like that denotes them as such. Okay? The word such that means an equation's coming, so we start writing the equation 5 times the sum. That's 5 parentheses. When I see the words the sum of, I'm looking for the word and to find out what I'm adding together. I'm adding the first and the third. First and third. That's n plus n plus 4. Okay, then we hit the word is, equals. We have a greater than, 16 greater than here, right? We don't always ignore greater than, less than statements. Okay, it's happening after is, so we'll be fixing the right-hand side. Then it says 9 times the second. I haven't used blue yet. 9 times the second. Now here's the second. How many pieces is the second? 2, right? To multiply 9 times 2 pieces, I have to put 9 parentheses n plus 2. There are understood parentheses in these problems. Be careful anytime you're multiplying by an integer. If the integer is being named by multiple things, which happens a lot, make sure parentheses go around it. And then the 16 greater than, haven't used orange yet. 16 greater than is going to be plus 16. Again, fixing the right-hand side because it happens after the word is. All right? You create a good equation. That equation is going to have an integer answer because we're trying to find integers. If the answer comes out n equals 17, it doesn't work because it's not even. It should be an even integer. Hopefully it will be. We'll find out. So, 2 options here. You can add n and n to make 2n plus 4 before you distribute, or you can distribute first and add like terms. I don't care. It doesn't matter. Both are the same to me. I'm going to add them together first. 5 parentheses 2n plus 4 equals, I'm going to go ahead and distribute this. I can't make that any prettier. So 9n plus 18 plus 16. 9 times n, 9 times 2. Plus 16 is outside the parentheses, so it's not affected by the 9. Here I just added these together before I distributed. Now if I distribute 5 times 2n is 10n. 5 times 4 is going to be plus 20. This is 9n plus 34. 18 and 16 add to make 34. We've got n's on both sides, numbers on both sides. I'm going to move my 9n because it has a smaller coefficient. Move the 20, so I've got to move the number to the other side. 10n minus 9n is 1n. 34 minus 20 makes 14, which is an even integer. It gives me belief that maybe I'm doing stuff right. All right. Again, if it came out n equals 15, maybe that's the right answer, but there are no even integers to do this, in which case you just throw out the answer. All right. So, let's say, and we're going to get to where we're multiplying these. You might get multiple answers. Maybe one works, the other doesn't. Throw out the one that doesn't work. All right. More often than not, I would say they're going to work. I'd say every time. So if they don't work, you probably messed up. But just know that if you did everything exactly right, you got 15 instead of 14. Empty set. There's no way to do it. All right. Final thing. It does say to find 3. We just found 1. We found the first one. So then we simply apply the pattern to get all the answers. So 14, add 2, add 4. There's your list of 3 that they're looking for. Prominently circled right there, so I know where your answer lies on your paper.